Today's objective is to solve quantitative problems involving stoichiometry of reactions in solution form. So what does that mean? Basically, we have quantitative problems, meaning we're going to be dealing with numbers. And stoichiometry is the same as the stoichiometry that you've learned in class when going from moles to grams and grams to moles. However, instead of masses, because we're dealing with solutions, we're going to be talking about volumes and specifically talking about molarity and its relationship to the volume of that solution. An example that we'll be using is if we have a molarity of 0.8 molar. That means that 0.8 moles of that solute is in 1 liter of that solution, which means we can use that as a converting factor in our stoichiometry problems, meaning that 0.8 moles of solute equals 1 liter of solution. This converting factor is similar to the converting factor we use when we go from grams to moles and using the molar mass. In this case, or this example, we have 18 grams of water equals 1 mole of water. An example of how we use molarity as a converting factor in our stoichiometry is in this quick example. If we start with 3 liters of solution containing 0.8 molar of NaCl, how many moles of NaCl are in this solution? We start with our equation, which tells us that molarity equals or means how many moles of solute in a liter of solution. So in this case, we calculate it to be that 0.8 moles of NaCl divided by 1 liter would give us that 0.8 molar. We can write this converting factor as 0.8 moles of NaCl is equal to 1 liter of this solution. We're then able to use that in our stoichiometry. We have 3 liters of solution. That's what we're starting with. And I'm used to doing it via a T-chart or H-chart. So that's what this is. It's the same as the multiplication sign. But we have 3 liters up here. So in order to cancel out liters, we need to put the 1 liter of solution from our converting factor on the bottom. So we have 1 liter of solution here, and that is equal to 0.8 moles of NaCl. And so that's why that one's on top. And then simple enough, because we're starting with liters and we're ending with moles, which is what we want, we then just have to do a little bit of math. And so 3 liters times 0.8 moles divided by 1 gives us that there's 2.4 moles of NaCl in 3 liters of this solution. Now that we know how to use molarity as a converting factor, it's kind of important to know how it's going to be used in stoichiometry. You're used to a pattern much like you see here, where if you're starting with grams, you need to first convert to moles of the reactant using the molar mass. You can then use the mole ratios to convert to your moles of the product. And then if you need your answer in grams, you can use the molar mass again to make it into grams. Well, now we're going to use molarity as one of the options to start with. So if your starting solution is in liters, you would know to use the molarity to convert that to moles, and then you can continue through your stoichiometry problem. If your answer needs to be in liters, you now know that you can go from moles of the product to liters of the solution using the molarity as the converting factor. So here's our first problem. I'm giving you the balanced equation which we'll use in this problem. As it reads, if the hydrochloric acid has a molarity of 0.82 molar, how many liters of it are needed to react with 28 grams of calcium hydroxide? Whenever I see a problem like this, it's important to understand the question before you begin. So that's where I start with step 1. You think about what is given. You are given the balanced equation, And why are you given the balanced equation? Well, it's so that you know the mole ratios. If you look, we're using the sulfuric acid, which is here in our equation, and we're using the calcium hydroxide, which is right here. So we're using both of the reagents. So if we look, the coefficient is 1 in front of the calcium hydroxide and 1 in front of the sulfuric acid. So that's why our mole ratio will be 1 to 1. The next thing the problem gives us is the molarity of the solution, which, as we saw in that first practice problem or that short example, we use that molarity to create that converting factor between liters and moles and liters. So we should know that 0.82 molar will be used as 0.82 moles of sulfuric acid equals 1 liter of sulfuric acid. Lastly, it's important to point out, what are you starting with? You're starting with 28 grams of the calcium hydroxide. Then the second step is just to be aware of, what do we want to convert to? We want to convert to liters of sulfuric acid solution. Once you have this, especially what you're starting with and ending with, we use that pattern that we saw earlier, where we're going to start with grams of the reactant, and we're going to end with liters of the solution. So our pattern is going to be through these arrows. We're going to go from grams to moles, then use the mole ratio, then we're going to use molarity to find the solution. Now when we go back to the question, basically the third step is do the stoichiometry. So I'm going to move these out of the way to have a little bit more room. And so remember, we're starting with 28 grams of calcium hydroxide. Now I'm used to doing stoichiometry using the technique called a T-chart, or some people call it an H-chart. So that's the method I'm going to use. Which we start with this converting T. On this side of the T is where we put our converting factors. And as we saw in the pattern, we first want to go from grams and convert it to moles. And we do that by using the molar mass. So the molar mass of calcium hydroxide is 74.093 grams. Now because we have grams up here, we want to make sure those units cancel out. So that number is going to go on the bottom. So grams is on the bottom. And then the moles is going to go on top, because that's the unit that we want. Remember back at that pattern, once we have it in moles, we can then use the mole ratio to convert it to that sulfuric acid. Now the mole ratio, because this coefficient's 1, and this coefficient 1, is going to be 1 to 1. So I extend my T out, or created an H. And because calcium hydroxide's up here, we're going to have calcium hydroxide on the bottom, again, to make sure those units cancel out. And the sulfuric acid will be on top. Once we have moles of sulfuric acid, we then wanted to convert it to liters of the solution. And we use that by using molarity to convert between moles to liters. So lastly, I convert my line again. And again, because moles is up here, we want to make sure that moles is down here so that the units will cancel out. And so because it's 0.28 molar, we know that there's 0.82, sorry about that, 0.82 moles of sulfuric acid in 1 liter of that sulfuric acid. So if we check, we're going from grams of calcium hydroxide to liters of sulfuric acid, which is the unit that we want. Once we have the unit we want, all we have to do is do the little bit of stoichiometry math. So if we look, 28 times 1 times 1 times 1 puts 28 on top in the numerator. We have 74.093 times 1 times 0.82, which makes 60.76 in the denominator. When we calculate that out, we get that there's 0.46 liters of sulfuric acid, and that's the final amount of solution needed for this problem. Now, if you're not sure about this H chart or T chart, and if you've never seen this before, it looks a little crazy. You might have done problems more with fractions or ratios. So if I delete these lines, and if I put in my multiplication symbols, this might look a little bit more familiar to you if this is the method that you use in class. The important part when doing it this way, just like the important part when you're doing the T-chart, is to make sure that your units cancel out so that all you're left with is the unit that you want, which is liters of our solution. So from this video, there's a couple hints and tips just to remember before you do some of the practice problems on your own. The first thing is, anytime you're converting from grams to moles or moles to grams, you're going to use the molar mass as the converting factor. Anytime you're converting from one substance to the other, the only way to do that is with the mole ratio, and you get those from the coefficients of the balanced equation. Lastly, what we're just using now is when you're converting from moles to liters or liters to moles, you're going to use the molarity of the solution in order to create that converting factor. To make it easier, just take a look at this picture. You all have one in front of you before you do your practice problems. And so if you're given grams, you know you have to convert to moles first, mole ratio, and then if you want your product in grams, you then use the mole mass of that one again to convert to grams. If you're given molarity first, you're going to use the molarity as the converting factor to moles and then continue through. If it's asking for your product in liters, you're going to then do that molarity problem at the end of the equation. So following this chart really helps understand the order of your stoichiometry before you begin your practice problems. So now that we've gone through the notes, it's now time for you to work on some practice problems, either on your own or with one other person, one other partner. Before you do that, I want you to think about how well do you understand the material. My number one rule of life is know yourself. You know how well you understand this material. Do you want to go straight to working on the practice problems, or do you think that you need a couple more examples before you understand the material? You do have the option, if you're watching these second videos and you're getting it, to turn them off and go to the practice problems. And you also have the option, if you're working on these practice problems and you think you need a little bit more help, you can go back to watching that second video. If you need my help, I usually ask that you at least watch one more example before asking me for help. Once everybody is done working on this practice problems, before class is over, everyone's going to do 3 problems that will be graded, that will be done on your own. So the purpose of the practice problems is to make sure that you understand the methods on how to use molarity in these stoichiometry problems. If you have any questions right now, you can ask me for help. Otherwise, you can get started either watching those second videos or on the practice problems. Good luck.